everyone. Today we are going to take our lesson on factoring polynomial expressions to another level. This time around, your expression is going to be equal to 0, and we're going to be factoring those expressions to solve an equation to find the x-intercepts of a polynomial function. Before we get started today, let's practice our factoring skills by factoring y cubed minus 4y squared minus 12y and 3x cubed plus 30x squared plus 75x. Please pause the video and practice factoring these expressions completely. And when you have an answer, please restart the video to see how well you did. All right, let's see how well you did. First of all, hopefully you noticed that all of these terms have in common a y. So factoring out a y, you would have y squared minus 4y minus 12. Now I'm going to put y on the outside and break apart the y squared minus 4y minus 12 into two parentheses. Splitting apart the y squared into a y and a y, I need to ask myself what two numbers multiply together to equal negative 12, but together add to equal negative 4. And I would say 6 and 2 would probably be my best approach, making 6 negative. So I'm going to have y minus 6 and y plus 2. There's nothing further for us to factor out from either parenthesis. Let's go ahead and look at example number 2. Hopefully you notice that all of these terms have in common a 3 as well as an x. And our leftovers is going to be x squared plus 10x plus 25. Now, x squared plus 10x plus 25, that is a perfect square trinomial. So that's going to be 3x times a parenthesis squared, and inside is going to be an x plus 5. And so that is your answer, 3x times x plus 5 squared. So, like I said to you in the very beginning, our objective for today is to solve polynomial equations by factoring. So that's our first I can statement. I can solve polynomial expressions or equations by factoring. That's where you set each parenthesis equal to 0 to identify what your x-intercepts are. Whenever you're solving an equation, that's what we're trying to find. The location on the graph where the graph crosses the x-axis. I also want you to be able to say, I can set up and solve a polynomial equation to solve a real-world problem. So we're going to be working with volume because volume's units is cubed, and that falls into our cubic polynomial kind of problems that we've had. So that's the type of problem we're going to be solving. So in order to solve a polynomial equation, we learned in chapter 4 that you use the zero product property. To solve factorable quadratic equations. That means that you let each parenthesis equal 0 and solve for x. That's what that means. So you can extend this technique for some higher degree polynomials, like to the 4th power, to the 3rd power, to the 5th power, etc. So what we're going to do is we're going to factor it using the same techniques as we learned in the last lesson, and then once we have our parentheses, any part containing an x or containing a variable is going to be set equal to 0, and then we'll be able to find our x-intercepts. So when you are asked to find all real number solutions of a polynomial equation, you'll need to factor completely, then set each factor equal to 0 and solve. You are not allowed to have decimals as a part of your answers, so no decimal answers. Here we go. We want real solutions, so that's what we're looking for, real solutions, so no imaginary solutions. So looking at letter A, we have 4x to the 5th power minus 40x cubed plus 36x. All right, let's start off by identifying a greatest common factor and simplifying this problem as much as we can. So 4 is divisible or can be divided into 40 and 36. It's a factor of both 40 and 36. So I'm going to factor out a 4. And all of these terms have in common at least one x, so I'm going to factor out an x as well. My leftovers is an x to the 4th minus 10x squared plus 36 divided by 4 is 9. And this is going to be equal to 0. So now I'm going to write 4x times 2 parentheses equals 0. I'm going to split apart the x to the 4th into an x squared and an x squared. And I need to figure out two numbers that multiply to equal 9, together add to equal negative 10, and that's negative 9 and negative 1. So I'm going to write x squared minus 9 and x squared minus 1. Both x squared minus 9 and x squared minus 1 are both dots. So both are dots. So we have to factor it completely. So we have 4 parentheses that we're going to have to set up. So we have 4x times 2 parentheses for the x squared minus 9 to be x plus 3 and x minus 3. And 2 parentheses for the x squared minus 1 to be x plus 1 and x minus 1. And this is equal to 0. So you always want your equation to equal 0. Please do not lose your equal 0 along the way. That is too important. So keep that equal 0 along the way. Now any part containing a variable is going to be set equal to 0. So that's going to be 4x equals 0, x plus 3 equals 0, x minus 3 equals 0, x plus 1 equals 0. And x minus 1 equals 0. So our solutions are x equals 0, plus or minus 3, and plus or minus 1. You do not need to show me this step right here. Simply identify the opposite number of what you see inside. That is all we are doing. The thing that's important though is that 4x is also going to be a part of our zeros. It's any part containing a variable is set equal to 0. All right, so now let's go ahead and look at letter B. Letter B, we have a problem. This is not equal to 0. We need it to equal 0. So the first thing I'm going to do is I'm going to subtract 14x cubed to the other side because it must equal 0 for these types of problems. So all of these polynomial equations have to equal 0. So my answer, we end up with 2x to the 5th power minus 14x cubed plus 24x equals 0. Now 5x cubed, 5x to the 5th, excuse me, 2x to the 5th minus 14x cubed and 24x, all are divisible by 2. They all contain an x. So I'm going to factor out a 2 and an x. And my leftovers is going to be x to the 4th minus 7x squared plus 12, and this is going to be equal to 0. So I'm going to put 2x on the outside and break apart my x to the 4th minus 7x squared plus 12 into 2 parentheses. I'm going to split apart the x to the 4th into an x squared and an x squared and ask myself what two numbers multiply to equal 12 but together add to equal negative 7. And that is negative 3 and negative 4. So I'm going to write minus 3 and minus 4. Well, you are not done because x squared minus 4, that is a dots, a difference of 2 squares. So we'll have to factor that even further. So we have 2x times x squared minus 3 times an x plus 2 times an x minus 2. That's going to be equal to 0. So every single portion is going to be set equal to 0. So the 2x will produce an x equals 0. The x squared minus 3, well, if you need to do it on the side, x squared minus 3 equals 0. To add 3 on both sides, you end up with x squared equals 3. Take the square root of both sides, x equals plus or minus the square root of 3. And that's because we're taking the square root of both sides. So our answer is going to be x equals 0 plus or minus the square root of 3, a positive 2, and a negative 2, plus or minus 2. And these are all of your solutions. Notice that we ended up with 5 solutions. 0, 2 types of square root of 3, 2 types of 2, plus or minus. And notice that our exponent was raised to the 5th power. Typically, that will represent the number of zeros that you'll have. You'll end up with 5 solutions, 5 locations on your graph where it crosses the x-axis. Let's go ahead and look at letter C. For letter C, we want this to be equal to 0, and we also want our leading coefficient to be positive. So I would recommend bringing the 12x to the 3rd to the other side. and bringing the 16x to the other side by adding 16x. You want your leading coefficient to be positive, and 2x to the 5th power would be our leading coefficient. So now I'm going to bring this over here for room purposes. We have 2x to the 5th power minus 12x cubed plus 16x equals 0. Now 2x to the 5th, 12x cubed, and 16x, they are all divisible by 2, and they all contain an x, so I'm going to put a 2x on the outside, and my leftovers is an x to the 4th minus 6x squared plus 8, and this is going to be equal to 0. So now I'm going to split this apart into two parentheses. Splitting apart the x to the 4th into an x squared and an x squared, I need to figure out what two numbers multiply to equal 8, but together add to equal -6. And that's -4 and -2. So I'm going to write x squared minus 4 and an x squared minus 2. Hopefully you're used to this by now. We're not done factoring because x squared minus 4, that is considered a dot, a difference of two squares that we need to split apart into two more parentheses because we're supposed to factor this completely. X squared minus 2 is not a difference of two squares like x squared minus 4 is. So that's going to be an x plus 2 and an x minus 2 in both of those parentheses. Any part containing a variable is set equal to 0. So the 2x will produce 0. Then x plus 2, x minus 2 will produce plus or minus 2. And then if you need to on the side, you can set x squared minus 2 equal to 0. Add 2 to both sides to end up with x squared is equal to 2. Take the square root of both sides and you end up with x is equal to plus or minus the square root of 2. Remember that whenever you take the square root of both sides, you end up with two solutions, plus or minus the square root of 2. And those are your 5 solutions, 5 x-intercepts. Go ahead and try letter D and letter E on your own. And when you have an answer, go ahead and restart the video. Letter D is a little tricky and you have to use the quadratic formula. Just putting that out there. All right, let's see how well you did. The first thing we want to do is we want to make our leading coefficient positive. So this 6x to the 4th has the largest exponent, and notice that it's not positive. So I'm going to add 6x to the 4th power to the other side. And when I do that, I end up with 6x to the 4th power minus 27x cubed plus 15x squared is equal to 0. All of these numbers are not very nice. So what we need to do is we need to factor out a greatest common factor, and it looks like 6, 27, and 15 are all divisible by 3. So I'm going to factor out a 3, and my leftovers is I'm going to factor out a 3, and I'm also going to factor out an x squared because they all have in common at least 2 x's. So dividing out a 3x squared from each term, I end up with 2x squared minus 9x plus 5, and that's going to be equal to 0. So now what I'm going to do is I'm going to try to factor the 2x squared minus 9x plus 5 and ask myself what two numbers multiply to equal positive 10 but together add to equal negative 9. Well, 1 and 10 would work, but if I made 10 negative, 1 times negative 10 would be negative 10. And so there doesn't exist anything. So that means that this is not factorable. But the directions asked you to find all real number zeros. So let's see if we can come up with real number zeros by using the quadratic formula. So the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And we're allowed to use the quadratic formula because 2x squared minus 9x plus 5 is quadratic. And we want to find the x-intercepts of the equation, and the quadratic formula will help us do that. So I'm going to, I already know that x equals 0 is one of my solutions, and that comes from 3x squared. So now I just need to find my other solutions. My a value is going to be 2, my b value is going to be -9, and my c value is 5. So I'm going to write x is equal to the opposite of b, which is 9, plus or minus the square root of -9 squared minus 4 times 2 times 5. This is all over 2 times 2, that's 2a. So I'm going to write x equals 9 plus or minus the square root of some number divided by 4. And I'm going to figure out what that number is. And after putting it into my calculator, I find that that's 41. 41 is not a perfect square number. It doesn't have any common factors in it. So simply our solutions are 9 plus or minus the square root of 41 over 4 and the number 0. These are our solutions. Those are our x-intercepts. And 9 plus or minus the square root of 41 is a real number, and that's because you can take the square root of 41. It's not imaginary, it is real. It's not very pretty, but it's still real. And finally, for letter E, x to the 4th plus 9 is equal to 10x squared. We want our leading term to be positive, and our leading term is x to the 4th. So I'm going to subtract x squared on both sides, or 10x squared on both sides. And when I do that, I end up with x to the 4th minus 10x squared plus 9 is equal to 0. Well, there's no greatest common factors, so I'm just going to split this apart into 2 parentheses, splitting the x to the 4th apart into an x squared and an x squared. And I need to ask myself what 2 numbers multiply to equal 9, but together add to equal -10, and that's -9 and -1. So I'm going to write -9 and -1 inside, and once again we end up with a double dots situation. So this is the dots and this is the dots. So we're going to split it apart into 2 parentheses because the directions say factor completely. So I'm going to split the x squared minus 9 into an x plus 3 and an x minus 3 and then an x plus 1 and an x minus 1. And my solutions are x equals plus or minus 3 and plus or minus 1. We have one more example and then we are finished for today. This is a problem that you will see on your homework, and then there's going to be a variation of this problem on your test. So it says you are designing a marble basin that will hold a fountain for a city park. The basin's sides and bottom should be 1 foot thick. Its outer length should be twice its outer width and outer height. And so that's what we have right here. Here's our outer length, it's 2x. And then we have our width being x and our height being x. We want to figure out what should the outer dimensions of the basin be if it's to hold 36 square feet of water. So the basin goes all the way to the bottom. So the basin side and bottom is 1 foot thick. So that's what we know. So if you can imagine on the bottom, it doesn't really start. The basin doesn't start until it's like a foot thick. Okay. What we are told is that the basin will hold 36 cubic feet. So that's the volume of the interior. So that's what we know. We know the volume of the interior is equal to 36 cubic feet. And we know that volume is equal to length times width times height. So what we need to do is we need to figure out how big is the interior length, width, and height. So that's what I'm going to write right here. The length of the interior is equal to something. The width of the interior, that's equal to something. And the height of the interior, that's equal to something as well. All right, let's analyze this really quick. So I'm going to go to my picture. Hopefully you can see it. Okay, so if you can imagine this basin. Okay, the length of the exterior is 2x, but on the inside it is 1 foot thick on each end. So that means that the interior's length is going to be 2x minus 2 feet, because this is 1 foot on one side and 1 foot on the other. So it's 2x minus a foot on each side. So that's your new length. Your new length is going to be, if we can find it, here we are. My new length is going to be 2x minus 2. My width of the interior, let me go back to the picture. My width of the interior. So my width started off being x, but this side is 1 foot and this side is 1 foot. So the width of the interior is going to be x minus 2 feet. So the width on this side is a foot, the width on this side is a foot, and it's going to be a lot smaller than what it is on the outside. So that's going to be x minus 2. So my width of the interior is going to be x minus 2. My height is a little bit different. Since my basin is open, we don't have any thickness on the top. But what we do have is we do have a foot thick on the bottom. And since the height is supposed to be x, it's kind of like x minus a foot is your height on the inside. So that's x minus 1. So your interior height is just going to be x minus a foot because it's open on the outside. So x minus 1. So now that I have my volume of the interior, my length of the interior, my width of the interior, my height of the interior, I can use all of that information to help me define what the exterior length is going to be, the exterior width, and my exterior height. That's what my goal is to find. So I need to find the exterior length, width, and height. But in order for me to do that, I'm going to use my interior information. So I need to solve for x. So what I have here is I have 36. Please write small for this problem, by the way. We have 36 is equal to my length, which is 2x minus 2, times my width, which is x minus 2, times my height, which is x minus 1. I'm going to do a massive FOIL in order to break this down into a polynomial written in standard form. So I'm going to FOIL, and we have 36 is equal to 2 times x, which is 2x squared, 2 times 2, which is minus 4x, negative 2 times x, which is minus 2x, and negative 2 times negative 2, which is plus 4. This is times x minus 1. I'm going to clean this problem up to make it simpler. And I have 36 is equal to 2x squared minus 6x plus 4. And I'm going to multiply that by x minus 1. So I'm going to do a massive FOIL. 36 is equal to 2x squared times x is 2x cubed. 2x squared times minus 1 is minus 2x squared. Negative 6 times x is minus 6x squared. Negative 6 times negative 1 is plus 6x. 4 times x is plus 4x. And 4 times negative 1 is minus 4. This equation needs to equal 0, so at this step, while I'm combining all of my like terms, I'm going to subtract 36 on both sides. So now I have 0 is equal to 2x cubed minus, I'm going to combine my like terms, and I have minus 8x squared. 6 plus 4 is plus 10x, minus 4 minus 36, that's minus 40. Now at this step, 2, 8, 10, and 40 are all divisible by 2. And since we are solving an equation, we can divide out a 2 by every single term. And you're allowed to do this if you're solving an equation. If you're factoring an expression, we would factor out a 2, not divide it out. So now I have 0 is equal to x cubed minus 4x squared plus 5x minus 20. Notice that we have 4 terms in our expression, and we know that whenever we see 4 terms, we're going to use factoring by grouping. So that's exactly what we're going to do, factoring by grouping. So I'm going to group the first 2 terms together, leave the plus sign in the middle, and I'm going to group the last 2 terms together. And I'm going to factor out a greatest common factor from the first 2 terms, and that's an x squared. So I have an x squared times an x minus 4. Plus 5x and 20. They both have in common a 5. And my leftovers is an x minus 4. So I have 0 is equal to 2 parentheses. One is going to have my outsiders, which is x squared plus 5. And the other one's going to have my insiders, which is an x minus 4. So I'm going to set each parenthesis equal to 0, and I have x squared plus 5 is equal to 0. And I'm going to subtract 5 on both sides, and I end up with x squared is equal to negative 5. And if I take the square root of both sides, I end up with plus or minus I square roots of 5, which does not make any sense since we are talking about width. So that doesn't appear to be our answer. Instead, our answer appears to be 4. So now that we know that x equals 4, we can now use the x equals 4 to find our exterior to the length, width, and height. So I know that the length was 2x, and 2 times 4 is 8 feet. My width and height were both the same, so they are both 4 feet each. And that is your answer. All right, that is the end of today's lesson. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day, and I'll see you next time.